All right, today what we're going to be working on is we're still working with vectors, but now we're dealing with something totally different. We're going to be dealing with parametric equations. Problem number 1, we are dealing with this particular point, negative 2, 1. So I want you to put a point right here. I want you to call that point P. All right, we're going to learn about vector equations. This is your standard form for a vector equation. It says x2 minus x1 comma y2 minus y1 equals this component called t, which is a scalar. It's a scale factor. A1 is your horizontal component. A2 is your vertical component for your vectors. This will be your vector equation. So we're going to eventually write the vector equation for this problem. And we're going to write the parametric equation for problem number 1. And this is the formula for your parametric equation for y, for x, and for y. So right now, let's look at problem 1. Right here you can see we have the point at negative 2, comma 1. And we're going to highlight a couple of things here. We're going to highlight it in, let's see here, I'll go purple. Great. So right here, from this point, I'd like you to go over 3 units. So from right here, we're going to go over 3. We're going to go down 4. Over 3, down 4. The horizontal component is a plus 3. The vertical component is a minus 4. Then just label it. You went over, but plus 3, and you went down 4. What I'd like you to do is I'd like you to put a point right there. We're going to label that point 1, negative 3. So we're at a 1 and a negative 3 right here. If I do that again, I go over 3 units, down 4 units. I'm at a new point. I'm at a 4 and a negative 7. And then I want you to draw your vector from here, and it's going straight down through 1, negative 3, through 4, negative 7, and that would continue to go straight down, going like that forever. If we started at P, we start here, start at this point, and go over 3 and down 4, that's what your vector would look like, and that would continue to go on forever and ever and ever. All right? All right, what we're going to do now that we've graphed this, we are actually going to make the vector equation that goes with this particular graph. All right? So what I'd like you to do right here is I would like you to do x minus what's called the x1 component. So if I do x minus a negative 2, what does that become? It becomes x plus 2. That's your first component. Then we say y minus what's called y1, and our y1 is just a 1. And so you're left with just y minus 1. So when you have a negative, make sure you know that it will change to a positive. But if you just have a positive number, just plug it in and you're done. Okay? So that's the first part. And that's going to equal t, which is your scalar. We'll explain what that means. Times, what was our A1? Our A1 is a 3, and our A2 is a negative 4. This is what's called the vector equation right here. All right, vector equation for problem number 1. So that's the first part of the answer that I'm looking for, is the vector equation. So what you would do is you go to problem number 1 right here, and you would write the vector equation. And what was our vector equation? It was x plus 2, y minus 1 equals t times 3, comma, negative 4. And there's your first part. Completely done. Now we're going to write what's called the parametric equation. All right. So right here, let's look at the parametric equation. I'm going to write parametric equation. So it says x equals x1. Well, what was our x1 in our problem? Our x1 is a -2. So put -2 plus t times a1. Our a1 is a 3. So we're just going to put plus 3t. So x equals -2 plus 3t. That's your first equation. Your second equation for your parametric equation is y equals your y1, and our y1 is the number 1. Okay. Plus a t times a2. Oh, ours is a what? -4, so we're going to put minus 4t. And that's your second answer you're going to write for number 1. Now I'm going to show you how to use this in the graphing calculator so you can actually check your answer. Because we're going to make a little table to help you guys be able to check your answer. So here's your vector equation, here's your parametric equation for this particular problem on number 1. So go to your graphing calculator. What I want you to do is I want you to get second plus 712, clear it out. So second plus 712, clear it out. So let's say you start from scratch. Go to the mode button, everybody. Go to the mode. Go down to where it says function, and you're going from the function mode in the calculator. Go to the right where it says parametric mode, and press enter. So now you're in parametric mode. Now, hit y equals in your graph and look what happens. You see how it's different than function mode? In function mode it says y equals, right? In parametric mode it says x1t, y1t. So what was our first? Take a picture of this. Ooh, it was -2 plus 3t. So what I want you to do is I want you to type in -2 plus 3. Now, see where the x button is? Right here?
It turns it into a t when you hit it.
That's right, because we're in parametric. So go down, and we'll go back to our problem. It says 1 minus 4t. So I'm going to go back to the calculator, and we're write 1 minus 4t. Now, if you guys would please, before we hit graph, I want you guys to do a couple things. First of all, go second zoom. We're going to format this, and we're going to put the grid lines on. All right, so put grid line on. Once the grid line is turned on, I want you to hit zoom, and we're going to do number 4. We're going to go to zoom 4. Then I'm going to take a screenshot. Now, this point right here, what is the ordered pair for this point right here? -2, 1. What did we start at over here? -2, 1. Okay? What happens with the horizontal and the vertical? It goes over how many units to the right? It goes over 3, and it goes what? Down 4. Now we ran out of room, right? Because we're zooming in on this graph, but you guys can see clearly that this goes over plus 3, and it goes down 4. That's where this part comes in. 3, -4. This is your A1. This is your A2. This is your horizontal component. This is your vertical component. All right. Does everybody see now that this graph right here is the same as what? This graph right here. Now you're going to look at your table. The table is going to look a little bit different. So we're going to make a table in your journal. Here we go. Here's the table you're going to make. You're going to have values for t. You're going to have values for x and values for y. So now, and we're in parametric mode, you are not plugging in values for x, you're now plugging in values for t. So we're going to start at 0, then we're going to go 1, then we're going to go 2, then we're going to stop. Now, when
when you are at 0, that's where your graph starts. If we plug in a 0 into this right here, we plug in a 0 for t. What's 3 times 0? What's 0 plus negative 2? Negative 2. Plug in a 0 right there. You plug in a 0 right here, what are you left with? You plug in a 0, you're left with a 1. Where did our graph start at? At a negative 2, 1. If we plug in a 1 right here, we plug in the number 1 right there. We got 3 times 1. What's 3 minus 2? 1. We plug in a 1 right here. What's 1 minus 4? Negative 3. Now, look at this point. 1, negative 3. Watch. Going over here. Look where our point is. So when our t is equal to 1, where is our point located? Our point is located at a 1, negative 3. Guess what this point represents? When t is equal to 2. When you plug in a 2, you get a 4, negative 7. Now don't take my word for it. Go to your table. Okay, second graph, look at your table. So right now, look at your table, and you can clearly see you start at negative 2, 1, then you go to 1, negative 3, then you go to 4, negative 7. Understand that t value is, if you scale it up by 1, this is where you are. If you scale it up by 2, this is the ordered pair you're at. If you scale it up by 10, you're going to be at a what? A 28, negative 39. So this helps you understand the parametric form, helps you be able to scale up your vector. Let's go back and take a look at it. Maybe you can see what I'm saying. How many triangles do you see right here? You see 1 triangle. How many triangles do you see right here? You see 2 triangles. So if t equal 10, how many triangles would you see me drawing? 10 triangles going down. That's how your vector is getting bigger and bigger and bigger. All right? Now, any vector that goes this way, that means you're going in the opposite direction. That's when your t values are not positive. That's when they are negative. All right? So, in summary, we had 2 answers that we're trying to get. The first answer is the vector equation. The second answer is the parametric equation. What does this negative 2 and this 1 deal with? This starts where you're starting from. Here you started at a negative 2, 1. What did happen with the horizontal components? They always went what? 3 to the right. What happened with the vertical components? They went 4 down. That's how you interpret the parametric equation. Okay? So before we leave, I'm going to write a parametric equation, and you tell me where we start at. Okay? All right. What point would I start at in this parametric equation? I'd start at a 5, negative 3. What would be my vector dealing with this problem? What's the horizontal component? What's it doing every single time? It's going 4 to the left, and how much is it going up every single time? It's going up 2. That's how you guys can interpret. This is just an example. This is not your problem. But if you saw a parametric equation that looked like this, you would know where it started, and you would know how much it would go to the left and how much it would go up. So let's say, right here, let's say this point right here is at a 5, negative 3. What's it going to do? It's going to go which direction? It's going to go 4 to the left, and it's going to go up 2. So what it's going to look like is this right here. Your graph would look something like this, and would continue to go up. This is if t is equal to a 1. If t equal 2, then it would go up 2 triangles and 3 triangles. All right, so make sure you know how to write vector equations and parametric equations.